Welcome and thank you for attending this session of Lexi's eDiscovery webinar series, Best Practices Advanced eDiscovery Search. My name is Stu Van Duzen. I'm the Marketing Manager here at Lexi. Our eDiscovery webinar series takes place once a month and we cover a wide variety of relevant issues related to litigation technology and legal data management. Today's webinar should last about 30 minutes and we'll have a URL to access a recorded version of the presentation available for anyone who registered early next week. If during our webinar there are any questions that you have or any technical issues being experienced, please email me at webinars@lexi.com. I will answer all the questions we can, but if we run out of time, we will be sure to follow up by email. And before I turn things over, let me tell you a little bit about Carson. As mentioned, Carson is a principal and co-founder at Lexi, as well as the architect of our eDiscovery processing and review infrastructures. Carson has a wealth of experience in software engineering and development, in addition to working as a consulting expert with the Lumen Expert Group. Carson received his engineering master's from the Danish Institute of Technology and his MBA from the University of Texas at Austin. With that, here's Carson with Best Practices Advanced eDiscovery Search.
Thank you, Stu. Let me just start out by an overview of where keywords traditionally are used in eDiscovery. And you can really think of it as a life cycle of the case, where it starts out with the early case analysis and the states calling. You get the, there we go. Well, now that you've had a chance to read the slides, it really just goes through the life cycle of the case, where we use keywords to call down the amount. Often we see a collection be called down to maybe 10%, 20% of the incoming data. And from there, we go in and use keywords for responsive or privileged review, and then finally for identifying key documents for deposition and trial. The pros of keyword searching is that it's fast and inexpensive. The quality can be quite good if it's done right, and it avoids a lot of the issues that we're having as the amount of data is exploding. The traditional linear review is becoming less and less of an option. So for example, if you have a couple of custodians, you might get 10, 20, 30 gigabytes of data, and you can very quickly see that you've got hundreds of thousands of documents. If it just takes a couple of documents a minute to review, that you're into many, many weeks or months of review. That's where the keyword search will be able to significantly speed up the process. So we face two problems with search, and that's that they can be over and they can be under inclusive. So you get too many junk results, and that's known as false positive. Positive meaning they came back as a result on the search, but false is they're not really relevant to what we're looking for. They can be a problem in that you just get too many documents, but they're not a problem in that all the things that we are interested in are still there. Worse are the false negatives, which are documents that we really are interested in, but they did not get found by the search term. And therefore, they're negative, they didn't come back. And those are much more severe. Let's see, difficult. I'll talk a little bit more about those in a second. There are some types I just want to touch upon that can't be indexed. I mean, you could have corrupted files, you could have file types that I'm not aware of. And for those, you're able to generally go in and look at the size of the document and compare it to the amount of text extracted. And they can easily be flagged that way as having problems. So in order to get the good search terms, we start out with a request for production, and then we have to go and find out what are the specific terms. So for example, I mean, one lawsuit I was involved in involved call centers, and the request for production might talk about follow the call technology. So this is a technology that allows people on the phone to take a call from a customer and then forward it to the manager. The manager takes over, but the recording is then seamless. So when you want to review that call later, it goes straight from the person that took the call to the manager. So it's the follow the call technology. But then interviewing the custodians, that terminology was not at all used within the company. They used cradle to grave. So everywhere they talked about follow the call, they would use cradle to grave. And it really takes this company-specific information to figure out what do they call it within this company. And you need to make sure that you really understand the jargon that's used. And actually, after several weeks of working with the case, it turned out there was a completely different division that didn't use cradle to grave, but they used womb to tomb. And so, again, new keywords have to be developed for that. So we have different options to make sure that we catch as much as possible. All of these options, when enabled, would actually increase the amount being returned by the search. And it's important to understand all of them and just how they affect your results. The concept search is just the thesaurus lookup, and so we'll get any kind of synonyms that are involved. Stemming will give things like if you're searching for running, it will also search for run at the same time. Any kinds of stemming of the word. Fuzzy is particularly appropriate when you have a lot of scanned documents that have been OCR'd. So it's optical character recognition. That process can lead to a lot of errors in the text where an L becomes a 1 or a 1 becomes an L. And then when you turn on fuzzy search, it will still find your word and it will allow for those kinds of one-off errors in the word. And then finally, phonetic returns the sounding words. Here's some examples. We search for trade and we get all the search results that include trade, but in addition, because concept search is turned on, we also get the swap and the quid pro quo and the barter. Stemming, you have trade, trading. Again, it's important to know when you turn these on, you're just going to increase the amount of documents returned. You're not going to limit it. And there's the fuzzy search. So if you misspell it, or you could be spelling it correctly, but the document has it misspelled, it would pick it up. And then finally, the Boolean searches are the ones that really allow you to go in and get they actually work as either expanders or limiters for search. An example of the expanders is if you use wildcard, then you can get quite a lot of additional results. Okay, so speaking of the limiters, these are the ones where you have the data set returned, and now you're trying to make sure that you look through it and you see a lot of noise documents you're not interested in. And then how do you filter those out? And they tend to fall in two categories. One is just looking at the extension of the documents. And there are some that may just not belong. For example, you could have, if you have a disclaimer in an email, and if that happens to pick up one of your keywords, now every single email is practically going to be, because they have that email signature. And then you can go in and construct things like with Booleans to make sure that you limit anything that looks like that disclaimer at the bottom. You can also go in on certain file types that you just know are not relevant. So if you have a log file that's being generated every day, and that one has everybody's email addresses in it, then you could exclude that by file type and then avoid having that included in the collection. Here's an example of limiting documents. So we want to find documents with these two words in it, Lay and Jeffco, but we don't want them to be more than 25 words apart. So the key is that you create your You create your searches. You're very mindful of the type 1 and type 2 errors. The type 1 being the false positive, where it's just noise, and the type 2 where it's false negative. These are documents you should have found, but you didn't. And so you look through the return set, you start to sample those, and you look at ways to limit that. You also sample some of the ones that did not get picked up, find more keywords, and include those. And basically the key point in my mind is that the whole thing becomes an iterative process where you do the searches, you see what gets returned. If you have, for example, 30 keywords, you can go in and create a list of how many documents were found on each keyword. You can do a Pareto chart, and you will often find that one keyword is now responsible for half of the documents being returned. And maybe that's true, but more likely that keyword is just too generic, and there's a better way of getting at the relevant documents. Okay, switching gears. There are typically two types of indices used in these litigation databases. Historically, and a lot of the databases still out there uses the image-based or OCR text extraction. So every document comes in, gets converted to a PDF or a TIFF page. That has the advantage they're easy to deal with. They can be bait stamped, and that way you can refer to a specific page very easily. If they're image-based, then the optical character recognition is applied to the document, and the result of that is the text that goes into the search index. So it has a lot of drawbacks, as we'll see in a minute. And then what is becoming more common is the extracted text, where we go into the original file and extract the text from the original, and that's what's going into the search index. However, that approach, while in general being better than the first one, also has some drawbacks. And we will see in some examples here how both of them have some severe limitations and how we can overcome those. Let's start with the one where the OCR is based on imaged files. So we take our original files, or native files as they're known, and we convert them into generally TIFF images, and then that gets OCR'd, and now that becomes searchable. And it's done through a process that uses a print driver, so the resulting TIFF image that you're viewing looks identical to if you had physically printed this document on the printer. Doing so means that it's dropping all of the information, such as headers, footers, comments, revisions, things, highlighted text. We even see highlighted text where when it prints it, it goes from a color version to a black and white, and sometimes that highlighting is dark enough to where that gets converted to black, and the whole thing looks like it's redacted now, when in reality it was just highlighted with a green instead of a yellow. So, but the point is, if you have things like a Word document with lots of revision control, all of that is now lost, and you cannot tell from the document you're looking at that information was available in the original. So here's one example where this one, on the left-hand side, we've got an image-based, we've got an image of our proforma form, and on the right-hand side, we have the text that will go into the search index. And because it was OCR'd, all that text survived, but the stuff around it, such as the revision that you see up there with the balance sheet that's changed to just sheet, that's lost. So in this particular example, that looks fairly good, but in general, you can lose a lot of revision history. So switching to the native extraction, we now go in and we extract the text from the native before it gets converted to a TIFF image. And the advantage is it gets all of the text, it gets all of the revision history, the author, everything. However, if you have anything that is image-based, then that will not get extracted because it is an image. So to the human, it looks like text, but to the search engine, it's just invisible. And here is an example, the same one as before. If we take the original document, now we do get all of the revision history extracted, but the entire sheet is now gone because it was image-based. So let me break out here and show an example in Excel. Okay. So let's suppose in Excel we have a long sentence. And then we have a shorter sentence. So you can see how the default behavior in Excel is there's no word wrap, and this thing just gets clipped. It's still there, of course, but it's clipped when we view it. Take that same document, we print it, and printing is the same thing that would happen if you're converting it to TIFF. It's the same process. So we're printing it. Where do you want to save it? We'll save it on the desktop. And now take our Excel, we open it, and now this is what it looks like. And if you search for Word, it is not there. It's simply clipped. And you can't always tell that that's what happened here. I can even go in and I can save the text out of this thing. And open the text. And here you go. This is what would be put into the search index. And the original information is gone. Okay. So that's the drawback of using the first approach, where we use the imaged version. Now let me show you an example of the drawback of using the first approach. So go in here, let's see, insert picture from the desktop. Okay, which is text-based, and then we go in here and say this image is not well, other way around. This text is not image-based. Okay, so we got this. If I zoom in, you can see as it gets really large, you can see how this is image-based. You can see that it's a little bit more jagged than the smooth text from the one that is the actual text. And if again we go in and we print this, let's call that book 2. This is the native extraction. It looks good, but if we go in and save the text out of it, this text is what will be put into the search index. And as you can see, the image-based text is completely gone. It's simply not there. So we now have we have two scenarios. One where the text is only visible if you OCR it, and the other one where the text is only visible if you do the native extraction. And so to overcome that, we will go back to the presentation. And then say that we have what we call the dual index. And so into the search engine, we put the extracted text into the search engine. Then we go ahead and we do all the OCR and the page-based conversion, and then we extract the text from that and put that into the search index as well. So for each document in the system, it will contain both of the extracted text. And in a lot of cases, those will be almost the same or identical, but in several other cases, you'll have the one that are specific to the document. And then this way, we capture both the embedded text, embedded images in Word documents or PDF, or just scanned document, as well as all of the hidden text like revisions and comments and what have you. And here's just a quick example from our website where you can see if you search for this term, it will show all the words that have this, and then we have different tabs in the viewer where on here you see the text from one, and on here you see the text from the other one. And so you're able to, you get all the results independent of where the text was, and you're able to see both versions. And with that, I'll turn it back to Stu.
Carsten, thank you very much. So it looks like we're just about out of time here. We do have a couple of unanswered questions that we will follow up to via email. If any other questions come up, please feel free to contact us at webinars@lexby.com. We will have a copy of the presentation as well as the slide deck available to anybody who registered early next week. So keep an eye out for that email. Just a little bit about Lexby. We're an eDiscovery software and service provider based in Austin, Texas, and we focus on helping legal professionals meet discovery deadlines through our hosted review software and high-speed processing services. So again, thank you all very much for attending today. Keep an eye out for our next month's presentation where we will be covering legal timelines and early case assessment. Thank you very much and have a great day.